Hi Ravanya. Hi Rajneesh.
Hello, ma'am.
Hello. Yeah. Good evening. Hi Shubham. Good evening.
खाना खत्म हो गया evaluation.
Hi. Good evening. Good evening Shubhankar, Shubham. Good evening Prag. Yeah.
Good evening,
Good
ma'am.
evening everyone. Venkatesh, Subhash, Nileshwar. Good evening. How is the course going? Do you feel, do you feel any progress in your learning? Are the CCs and assignments useful?
Yes, ma'am.
Are you learning every day? That's the important thing. Even if learn a small concept, that should be clear. So because we have only the databases part pending, okay. You should be able to develop you should be able to develop an application by now. Okay.
So, ma'am, our backend is completed, no?
By backend concepts are completed. Okay, we still have databases, which is half of the part of the backend, persisting datas. Okay, but a node is completed. Okay, just you will have to learn about Mongo or SQL, and you will have to learn about how to integrate that with your Node application. Right, so that's the only thing pending. And yeah, testing is pending, but that should not stop you from developing an application. Redis, I don't think we will cover it in our curriculum, Nileshwar. That is a slightly advanced concept. Okay. We'll see if time permits, for sure. I'll take it. Rupam, just done with the evaluation. Okay, got it. Yeah, I'm adding the MCQ. I'm adding the MCQ for Tata, added for Baba as well. Yeah. So kind of tricky. Okay. Just learn, know if you don't know how number.san and a simple SNAN is working, browse how it's working and then try to answer. Again, MCQs, as I'm telling from day one, just take it as a learning, don't feel bad that if you have answered it wrongly. Okay, just take it as a learning perspective, because it's near to impossible to cover every tiny details in class. Okay, through MCQs, we learn new stuffs here and there. Yeah. Just browse how both of them are working, what it does internally, and then try to answer. I have given 3 minutes. gRPCs are, give me a minute. I don't think we have Mongo 5 sessions. I don't think even in 5 sessions we'll be able to complete entire Mongo. Yeah, we have SQL, we have GraphQL, we have WebSockets, we have testing, and no, we don't have gRPCs involved, Shubhankar. Yeah. Our objective is to, all these are good concepts to, to just add in your skill sets. Okay, definitely you will stand out if you know Redis, if you know catching, if you have worked with catching and all. Yeah. So after completing the syllabus, if time is left and here and there, if we have got time, definitely no, I'll take up the concepts which you are taking, which you want me to discuss, and we'll see it. Because we have a React, okay, which will definitely take a month. Okay, React is cool, not cool. Okay, React is something most demanded skill in today's industry, right? Like with plain JavaScript, uh, too much of overhead in the developers point of view. Okay, with plain JavaScript, and it's kind of slow when you develop an entire application. Okay, with plain JavaScript. So we have a huge React topic itself. That's the module 4. Okay, once we are done with that, in between the no project sessions, if time is left, we will take additional concepts. Okay, cool. Let me share my screen. Is my screen visible? Okay.
Yes, ma'am.
Yeah.
Yes, ma'am.
Please mute yourself, Sadik. Yeah, thank you. So any doubts with Node.js? I have few concepts. I have noted it down to explain in extra sessions, but that's out of the curriculum. Other than that, no, the concepts which we have seen already, any doubts with till there? If you want me to repeat any of the concepts which we have seen already, let me know in the chat box. Okay, I'll bring it up this Saturday. So what was yesterday's topic? Yeah, yesterday's topic was more on environment variables, right? Like configuring environment variables, working it with that in local and configuring the same in Heroku, and then accessing environment variables. And then we saw custom validations using Express Validator, how to create a schema, some advanced concepts in Express Generator itself. Okay, we saw 1 or 2 sanitizations, right? Like explore that package. Okay, don't reinvent the wheel. Most of the validations which you will be requiring in your application is already implemented in that third-party package. Just use that. Okay, so any concepts with on that part? No? Yes? Can we start with databases?
Yes, ma'am.
Yeah. So far, what were we using to store the data, meaning to persist the data in the application? How did we deal with data so far?
For
JSON file and
Yeah,
editing
JSON
the
files.
file,
Yeah.
management the file.
So through files we were doing it. We had a JSON file. I added data to my JSON file and then read it from the JSON file. But updating and all we didn't see because it's complex. You need to parse through the entire content of the file and then do it, right? But we were managing data and persisting using JSON files. Okay, you can do with any format of file whichever you wanted to, but we were dealing with files. Okay, the other one was memory, right? In memory, that we are not persisting the data. Okay, just when the server stops and starts, all your data in your memory will go away. Right, but JSON files, you were able to persist in one way or the other, but retrieving information, editing information was much complex even in files, right? Correct. So tell me, what are the disadvantages like in the approaches which we all saw already? Anyone?
Disadvantages in that sense, ma'am. For what? Like storing the data or what?
Yeah, storing the data, like what are the difficulties we were facing when we were not able to persist the data and we were using files or in-memory type? Yes, Nileshwar, Kyle, correct. File operations are slower. Updating the entire updating and entry in the file is costly, meaning, as you said, slower. Okay, in memory, data gets lost, like, okay, data loss. Here, once the server stops, here, slower, which is much slower. Yes, correct. Much memory takes up too huge when the file size grows. Let's say you have millions of users in your application. Okay, the data, storing all the data in different files will still make the file size huge and it will occupy a huge memory. Yes, you can still use it as use streams and read chunk by chunk, but still too much of processing to be done, okay, to read the entire content of the file. And basically querying is also slower. Let's say you want to get all the users whose age is less than 18, right? So querying, you need to parse the entire file, get the data, split it. Even the data is not formatted, it can be of any type. right? So it's the processing takes much time, the memory it's slower, querying becomes difficult, too much of code, too much of overhead in the developers, when they are writing the code, right? This is not much efficient, and we need to persist the data. By persist, I say, by mean, we need to have the user's data. Okay, even when the server stops, we need to preserve users data. Users data cannot be lost when the server stops. Okay, so we need to persist the data in the disk itself. Okay, and we need databases for that. Okay, to store your data in the disk, and also to store the persist users data, and any information related to the related to the users, you should persist them in a database, so that you can retrieve in a much faster way. Okay, perform some computations, querying should be faster. Okay, you should be able to get data as fast as possible from the disk. Okay, from the disk, so that you serve your customers in a much faster way instead of parsing the files and getting the data. Okay, performing analytics, meaning, as I said, getting, let's say you want users from India, right? You might have plenty of queries like this which you wanted to do on a, in the application. Let's say you have a list e-commerce application, you have Amazon, right? So when you query based on categories, you can query based, you can apply filters, right? You can search, you can apply filters on multiple attributes. Let's say you are looking for a dress, right? From the category clothing, you can go and apply filters for men and women. You can apply filters for your size, the color you want, the material you want. There are plenty of filters which you can apply, which is you are applying criterias in the data available in the database, and then you are querying. So this querying will get complex as you give too much of flexibility to the user. Right, so when you have too many filters that the user can apply and get the results, you should be able to design an application in such a way all the user queries are handled and served in a much faster way. Okay, having that much plenty of criterias and storing data in files and parsing them will take a day to know. In Amazon scale, it will definitely take a day to parse the files of the content of Amazon, right? So it's time consuming process, so we need a database to have the data in the disk, and also query, retrieve, insert, update and delete data in the disk in a much faster way. Okay, so based on based on the application you develop, okay, the amount of load on each of the operations, by operations I mean insert or update or delete or reading, just reading, based on the application you develop, the amount of load on each of these operations differs, right? So let's say, let's take YouTube, right? Do you think which operation is more used? Do you think the read operation will be more, or the write one?
Read.
Read, right? So when you compare read and write, when you take YouTube, obviously read operation is much higher when you compare to write, right? So again, can you give me an example where write operations are large?
Facebook. Otherwise,
Facebook still, the amount
LinkedIn.
of people who write the content is far lesser than the amount of people who read the content, right?
Yeah.
Can
So
anyone of you
otherwise,
give example of
Twitter.
how? Twitter content creators are far less when you compare to content readers, right? Any example of application where write operation is greater?
Logging.
Sorry,
Blogs, ma'am.
Blogs, no.
logs.
Not
Yeah,
actually.
Again.
similar to Twitter.
Yeah.
Instagram.
Instagram.
No, ma'am.
Just think. Even I don't get it handy. Let's see. Read heavy operations. Sorry, read heavy applications.
Read or write heavy application, ma'am.
Right heavy.
Any chat applications?
Sorry.
Any chat applications?
Any
Chat applications.
chat application. Yes.
Yeah.
Chat application will work, right?
For
So
sure.
it's probably kind of equal or greater, right? Either the read and write are equal or write is greater. Because the write is the first operation, and then there is a possibility that some of them are not reading it, but write would be, you can say that it's a write heavy application. Okay, there are plenty of applications, but I don't get it handy, but let's see. Yeah, think about it. You can also browse. Let's see. Okay, we'll see that later. So based on these operations, okay, the load on your databases will also differ, and the kind of database you choose for your application will also depend on whether your application is a read heavy application or a write heavy application. Some databases are designed just to support read heavy applications, whereas certain applications work better for certain databases work better if your application is read heavy. Got it? So when I say databases on a very high level, okay, databases on a very high level are classified into two categories. Okay, the first one is RDBMS and second is NoSQL. Okay, this RDBMS stands for Relational Database Management System.
Hello.
Okay, yes.
Ma'am, am I audible to you clearly?
Yes, Sudhakar. Yes, Sudhakar.
Actually, what the screen is lagging maybe. It is showing slowly the RTBMS.
Is it?
That
Is it
time.
for everyone?
No, ma'am. No, ma'am. No.
Okay.
That's why I asked am I audible to you clearly?
Okay. Probably try reconnecting it if
No,
the
no,
issue
now
is still
it's clear.
okay.
That time.
Okay. So NoSQL, there is, again, some people say it's, it's a non-relational SQL, and not only SQL, or non-relational database, non-relational DB. Okay, so basically anything other than relational databases, you name them, you categorize them under NoSQL databases. Understood? Okay, so let's see what relational database is, and let's compare, between these two databases like the SQL and RDBMS and NoSQL. Okay, let's see in what are the scenarios one will perform in a better way than the other. Okay, as I already told, it's not similar to sessions and JWT, right? It's not one is always better than the other. Okay, depending on your application, depending on your use case, okay, you will have to consider multiple criteria to discuss on whether you will have to go to relational database management system or NoSQL. Okay, so let us say, let me first explain RDBMS. By word itself, you can see there is some relationship between the data which you have stored. Okay, let's first let me list a few examples. If anyone know, can anyone of you tell me a few examples for relational databases?
SQL, Oracle,
Postgres
Yeah,
MySQL.
and Postgres.
yes. Yeah, so MySQL, SQL, Oracle's one, and Postgres, right? So any examples for NoSQL?
Mongo DB.
Mongo DB, Cassandra, and Couch, Redis.
Correct. Cassandra, Couch, Dynamo.
Dynamo also.
Yeah, Dynamo is from Amazon, right? And you also have Big Trek, I believe. Give me a minute, from Google.
Dynamo, ma'am, you have here, if you are doing search, then it will show is a PUBG player.
Yeah. There is one database from Google, Big Data or Big Trek.
Big data also there.
No. Yeah, I'm not sure about the database that the Google is using. I think it's somewhere big. I don't remember. Big Table, yes. Big Table. Yeah, each company have their own databases. I think somewhere around Big, yeah, Big Table might be correct. I'm not sure. Okay, so these are examples of non-relational databases which comes under NoSQL. Okay, when you take relational databases, let us consider the e-commerce application itself. Okay, so you have customers, that is you and me. Okay, we have customers, right? Customers make an order, right? And each order must contain any products, right? Minimum of one, right? So this is the flow. So on, each one of each company based on their use case have their own design to have this in RDBMS. Okay, on a very general level, if you take, there must be some table. Okay, relational databases are nothing but data stored in tables
Row
in
and
the
column.
format of rows and columns. Understood? Okay, so if you have, say, this is the customer table. Okay, you can have multiple columns here. You can have ID, can have name, okay, address, okay, multiple data. Okay, so each, let's say ID 1, let's say yeah, it's Abhishek, and let's say ID 2, it's Dharn. Okay, so all our details are stored in this database in terms of rows and columns. Okay, every row is an entry and every column is the data for each of the entry, right? Name columns which contain all the names of the customers. Address column, let's say you have date of birth, or let's say you have region, right? From which region are you? All the details related to your customer, related to the customer, will be stored in this customer data table, which is a 2D data, which is stored in terms of rows and columns. Understood this much, like how data is being stored in relational databases, which is in terms of table and rows and columns?
So, ma'am, How we do have to store that data?
Yeah, you create a table, okay, and you insert rows here. Like you need to give, like this is the you need to mention ID is an integer, right? And name will have hmm,
Using what which language? Python.
no, MySQL have their own commands to create a table. You need not have language and all, right? It's you have command queries which you use to add data, delete and edit and all those. Okay, you use that queries in your programming language to insert stuffs in your table. Okay. So if you see here, you need to create a table first. Okay, I'll give you a few points before itself, and then we can compare, how both of them differs. If you take RDBMS, in order to insert data, in order to insert Abhishek and Dharm or anyone else data in the customer table, first you need to create a table. Okay, tell your database, that is either MySQL or Postgres, that this is my table and this table contains ID, which is the primary key. Okay, we'll talk about that primary key and all later. Okay, which has ID, which has name, which has address, which has date of birth, region, and you also need to tell that this ID is, will have numbers, name is a string, and address is again a string, date of birth is a date, again region is a string. So you need to define the schema. Okay, do you understand the word schema? Even yesterday we used schema is basically the structure or design, yeah. So before doing something, you define the structure or something like a blueprint, you can say. Okay, that refers to the schema. Okay, so before I have to enter, if I have to enter any data in this table, if I have to enter 3 4 5 6 7 8 those many customers in my table, before even entering, I need to define the schema of my table, give the table name, mention the number of column, mention the type of each column, and only then you will be allowed to add data into your table. Is that part clear? Let
Yes,
me list here. You'll have to define the schema. Okay. So now let's come to the process which I told. Okay, you can have customers, you can have orders, you can have products, right? So one customer can make multiple orders. Yes, I can order anytime I want in Amazon, right?
Right.
Yeah.
Yeah.
So basically, it is not, they will not add it in one table itself. Okay, there is a concept, if anyone is from CS background, okay, there is a concept of normalization in database. Okay, there are 6 or I think, yeah, 6 or 5, I don't know. Okay, I don't remember. Okay, there are normalization steps that you need to perform when basically by normalization, the design criteria, how you should design your data tables, right? What are the criterias you will have to keep in mind when you are creating tables? There is some normalization which you have to follow. Okay, based on that, it's not, you should not have all the order, all the product and all in one table, because how will you give the column name here, right? One user can have multiple orders. Okay, so you need to create a separate table, okay, which is order. Okay, what will the details you will have in the order table generally?
ID.
Order ID.
Yeah.
Order ID, then
Product name.
Yes.
Quantity.
Customer warranty.
okay, now let's come one by one. Okay, one of you said product name, one of you said quantity, right? Product name, again, each order have multiple products, right? Similar to how one customer can have multiple orders, each order can have multiple products. So instead of having product in the order table, I should create another table to list the products in each of my orders, right? So let's finish the order table. Again, price. Are you telling about the total price of the order or each price of the product?
Total price, ma'am.
Yes. So
Total price.
each price of the product will go in this table, whereas total price of the order will come here, right? Total price. And we are missing one other important stuff. Yes, order ID, order price, good. Probably the address
Quantity.
where, probably the address where you are delivering the no.
Billing address, amount.
Yeah, yes, amount done, billing address. Yeah, one other
Quantity, ma'am.
important thing. Yeah, quantity. Okay, you can still have, but one other important thing.
Car.
ID of that object is like in which whole data will be mapped.
We have the order ID. Is that what you're telling?
Order ID, no, it's order ID can be means like on the basis of multiple product. It can be a sub order ID also, right? They have a multiple product if that.
Okay,
So we
okay,
have
yeah,
to make it
understood.
like a body
Hmm.
in which all the things will be mapped, so we can make it unique for the order in a process of uniqueness of the count of order. And order ID can be used as it is like the count of order for that particular products, how many times. So that will
Got it.
make it
Got
more is like appealing things for understanding the data and represent it to the another person.
Okay, you are, that is good. Okay, when you are developing an application, yes, good design concept, but let's not go that complex. Okay, let's not uh, make our data structure complex. Okay, let's stick with one order ID and then no, let's make this as a unique one. Okay, but one important thing, like let's say order ID one,
Product
total
type.
price, product type, no, 1,000, and then let's say I'm delivering it to some XYZ, is it? And then quantity, okay, let's say 5. Okay, whatever details you wanted to add. But how will I know this order is being ordered by customer 1?
Customer ID.
Yes, customer ID. That's important, right? Just having order details like this, how will I get to know which order is placed by which customer? Who placed which order, right? That detail I need, right? Like else, how will I know from thousands of customers who placed order 1?
Yeah, ma'am.
Okay, so that is important, right? That column you will have to add here. You will have to add the customer ID. Okay, this customer ID is what we call it as no relationship. Okay, so this customer ID must be present in this database, right? Like in this table. Correct. Only if the customer is present in this table, you should allow them to place the order. So basically, there is some relationship involved here. Am I right?
Correct, ma'am.
Correct. Similarly, let's go to products table. Okay, you will have product ID. Okay, you can have product name,
Price.
uh, type, and all the product definition will have. We need to have what are the products placed in this order. Let's have product ID, name, and price, because price might differ from each time when you place the order. In this month the price of the product will be different, next month it will be different, right? So let's have the price and whatever you wanted. Okay, basic details type or whatever details related to the product you can have. But here also you need to know if this product, let's say product 1 or product 2, 3. Okay, let's say if these 3 products are from order 1, you need to have a mapping that order ID. Okay, order ID is 111 here. Understood? And only then you will be able to get, okay, if I say, if I need to get all the products from order 1, okay, I'll simply go to this table, get the order ID 1, and then get all the 3 products.
But
Is
we
that
can
clear?
also use join function for that. Why it's necessary to make a order ID column in product?
How will you make join function? How will you make join query?
By the name, product name.
Product name is there in order ID. How will I make the join function here?
By
On which criteria?
product name. Product name is unique, right?
Okay, let's have product name. Like basically the query which I'm asking is, let's say the order ID is 1. I need to get all the products from order ID 1. How will I get it? So if you say that it is product name, you need to have the product name in this table, no, to make the join query in the first place.
So in order table, product name is available as
No, how will we are not having product name here in the order table. We have
okay.
order ID, the
Also
total
means
amount.
like, instead of creating order ID in product, we can map in order table a product means like product ID.
That you can do anyway, like product ID. So what will happen? Yes, you are also correct, right? Instead of, let's say, I can add an additional column here, okay, and have product ID, right? So this is what you're telling.
Yeah,
Okay,
exactly.
so
It's like that
what will
only,
happen? Yeah, what the issue is here? One order can have multiple products, right?
right,
So they can
exactly.
have, so what will happen is you will end up repeating the same thing, same details, X, Y, Z, 5, let's say customer ID 1, customer ID 1, product ID 1, product ID 2. This kind of repetition is against the principle of normalization. Okay, you, as I told you, there are certain design principles that you'll have to follow when you design a table. When you say this is again possible, you can still query, yes, cool, from the order table itself. When I get order 1 again, but what you end up doing is, let's say one
Uh,
order contains
I
hundreds
have
of
one more
products,
question. Like,
right?
opinion. My opinion. I have one more opinion.
Yeah.
Like we are going to learn about the Mongo DB, right?
Yes.
So there's no part of a SQL. That's all depend on NoSQL. So instead of repeating the order ID again and again, we can
Mm-hmm.
map the product ID in an object in product ID column of the order table.
Yes, yes. When you go to NoSQL databases, the design and the it will become an entirely different thing, right? A different kind
Right.
of discussion, right? It's a JSON object, so you can have all of these in a one single object. Like, let's say order, and you can have products array with all these products. Okay, now we will see about RDBMS and then understand the disadvantages here. Okay.
Okay. Okay. Okay.
Okay, yeah. So what, just for the information of others, what he told was to add product ID also in the orders table. So that if we implement that, we will end up having duplication of multiple rows with the difference of just the product ID. As I said, that is against the the normalization steps. So you should not end up repeating rows just because you have different entries in one single column. Okay, and that's the reason you need not add product ID mapping here. Just add order ID here. So, once you have relationship with the order ID, you can simply go and query for order ID and get the products. Okay, so
Ma'am,
now,
one thing more.
yeah.
In product table, as like product ID is one and order
Mhm.
ID is one.
Yes.
For the product ID one, there can be multiple orders, right? Like order one,
No,
order
no,
two.
no, no, right? So it's not a general product, it is one unique product, right?
Yeah,
I
so
and
unique
you, I and
can be
you cannot
multiple orders.
order one, yeah, let me complete. I and you cannot order the same product, even though it's the same product, each one is different.
Uh, means like product ID is unique for a particular product, or it is means for the order ID comparison. Product ID is unique for the product name, right?
Yes, yes.
So, like product is X product is ordered by the multiple users.
Correct, correct. But what I'm saying is, let's take,
The same thing will happen as like order table. Again, the product name will be means
yeah, let's take
multiple.
Samsung phone. Okay.
Right.
What you are, I think what you are assuming is, uh, this will have one unique ID, right? Product
Right.
ID. Okay, but
Exactly.
that will not be the case. Okay, there are hundreds of products, hundreds of Samsung phones. Each phone will have a unique ID. Okay, it's
No,
totally up to the design, how you design it. Okay, we are not discussing about the design aspect of how you wanted to frame your tables.
no, my
Hmm.
question is like, as you told earlier, like order ID in order table, there can be multiple order ID if we map the product ID, right?
Yes.
So that's my question is like a product ID. If the Samsung phone is a Samsung phone, you can let's take the Samsung phone X
Hmm.
model,
Okay.
that particular unique phone. So that unique phone have a unique ID.
Yes.
So that unique phone can be ordered by the multiple users. Like I'll order, Rupam order, Ibrar order. You may also order that phone. So there are 4 order ID for that Samsung
Still,
phone.
yeah, okay. Still, you and I are getting different entity of the phone, different phones, not the same one. So generally, your product has a different ID, and I have a different ID of phone. Even though the phone name and the phone model is same, each phone will
Okay, okay.
have a different ID. Okay, one
So,
product ID will not be same. Okay, you cannot design a system saying like 100, let's say a product one, and it has 100 products, and
so
each
in
everything.
that case means like one product name can have multiple product IDs.
Yes. So even the product itself, it will go, deep, like product type category. Product type will have a particular ID, and then you can have, general ID for the product, and a particular ID for each of the quantity of the product, right? So we are mapping only the particular quantity of the product. Like let's say you and I order the same phone, your phone will have a different ID and my phone will have a different ID. Both are not same. So that mapping only I'm going to store here, and not the product type ID. Is that clear,
Okay.
Shubham?
Yeah, yeah.
Okay. Yeah. So again, it depends on how you design it. So I have considered to be this one, and this is how mostly we design it, right? Even though everything comes together as and one category. Okay, you cannot
Yes.
have the category ID here, because each one
Mm,
will order different no unit.
exactly.
Okay, yeah. So let's no for others, let's don't confuse with the design aspect and all. I'm just telling you how the relationship works in relational databases. Okay, so yes, Srinivas, I'll repeat it. Okay, relational databases, okay, are normally 2D type of a data, where all the data are stored in tables, and each table will have rows and columns. Okay, your columns will have uh, no a particular field data. Let's say you have a customer table. Each column will have a particular data about the customer. You can have name, address, date of birth of the customer, region. Everything will go as a separate column, and each row will contain all the details of your customer. Okay, is that part clear? Table, rows, columns, customer details.
Yes, ma'am.
Okay. So next, what I told you, I was trying to explain the relationship, how it is being done. Okay. Let's say a customer makes an order. A customer might make multiple orders. So what we end up doing in relational databases, create a separate table, order table, list all the details of the order. Okay. And together with that, okay, this row will not be there. Okay, order ID 1, total price, all the details related to the order. In order to know which customer placed this order, you add an additional column called customer ID in orders table. Okay, and then each of the ID here, right? Let's say this order is placed by customer 2, customer 3. All the customers which are listed here should be part of your customer table itself. Let's say you have a customer ID 12. Do you have a customer with ID 12 here?
No,
No, right? So it's not a valid relationship. So you normally we are maintaining a relationship between the databases, so that when tomorrow when I try to ask what are the orders placed by customer 1, you should be able to retrieve all the details of the orders placed by customer 1 from orders table. How we query that and all we will learn separately. Basically, there is a relationship between multiple tables here. Understood?
Yes.
Just a theoretical part. If you get it, that's more than enough. Okay, so this is how RDBMS works. Okay, as I told, you will have to define that space is gone. Okay, you will have to define the schema first. In order, by schema I mean what are the content of my table, what are the types of each of my column. Everything has to be defined in first place. Okay, before you actually add the entry in the table, you will have to define your schema first. Okay, I'll also mention few advantages and disadvantages of RDBMS. RDBMS follows ACID properties. Okay, whereas NoSQL doesn't. Okay, so can you say what? Can anyone of you tell me what ACID stands for? Do anyone know? Atomicity.
Atomicity, consistency, isolation,
Yeah,
and
atomicity, isolation. Sorry, consistency.
yeah,
Consistency, isolation,
durability.
and durability. Okay, I'll explain. We will go through what each one of these terms are when we are seeing SQL. Okay, for now, just keep in mind that your RDBMS follows ACID properties, and that is the reason even in banking applications, even today, RDBMS are used. Okay, because you want consistent data, you want atomicity to be followed, you want all these to be followed. So banking, financial applications all uses relational databases only, because your NoSQL databases will not follow these properties. Okay, we will see what each one of them, and we will see the example when we learn more about SQL. Okay, and the third thing is RDBMS supports vertical scaling. Okay. Can anyone of you explain what vertical scaling is? Okay. Consider an example of, let's say you have a system, you have a computer, okay, with 8 GB storage, okay, or 8 GB is too small. Okay, let's say you have a 16 GB of storage in your computer. Okay, so once you are done with filling up your storage with tons of movies, okay, I think one movie is of minimum it should be 1 GB, right? Like it goes up to 2 to 3, right? So let's say you have filled up with the movies and you have two options later. You are all your 16 GB is done. Okay, what can you do further? Okay, there are two ways. What you do to have additional storage? What do you do?
We can add like cloud, so like on other we can store that video to our what I say that
The
Google
other
Drive.
device? Okay, Google. Yeah, let's not go to, yeah, in today's world you can do and copy and then clean up your 16 GB of memory. But let's say you don't have any other smart answer though. Okay, let's say you don't have any other storage and you cannot empty this and all. What you do to have additional
Add
I
another
can
memory.
buy a pen drive and put it all on it.
Let's not have pen drive also. I'm expecting another answer. You don't have there are two ways basically. Either I add additional storage to my computer itself, I increase my hard disk,
Okay.
right?
Right.
I add few resources, I increase my hard disk speed, right? Like sorry,
Yes.
speed, so not speed, the storage part,
Storage.
increase hard disk storage, right? I buy a bigger storage, let's say I buy 32 GB hard disk and then I add it. The other way is buy another computer. This, let's say this is computer one. Let's say you can buy another computer itself with same 16 GB, right? So you can use this additional space here, or you will get 16 GB of additional space if you can afford for a hard disk. So when you try to add additional hard disk to your existing computer, that that stands for vertical scaling. Okay, you're actually scaling up. Vertical scaling is also called as scale up. Okay, increasing the capacity of the existing system itself. Basically, I have 16 GB. Now I have scaled up and then I have put 32 GB, right? This is scale up. Okay, when you go to horizontal scaling, that is basically scale out. Okay, which is otherwise called as horizontal scaling. Okay, the example of horizontal scaling is, let's say I have computer one with 16 GB. Okay, I scale out, I scale it horizontally. I buy additional computer C2 with same 16 GB. Okay, I scale out here, whereas I scale up here. Understood the difference between what vertical, excuse me, what vertical scaling is, what scale up is, and scale out is horizontal scaling?
Yes.
Any
Yes.
doubts? Basically, think of a building. Okay, let's
Ma'am,
say you
once
have,
again, can you explain the scale out?
yeah, I'll tell you. Okay, let's say you have a building. Okay, scale up. Let's say initially this building has 2 stories, like 2 floors. Okay, so let's say if by scale up, what you do is, imagine that you are additionally adding floors here. Okay, you are adding additional floors to the existing building itself. This is scale up. In terms of computer, think in terms of adding resources, hard disk, or your RAM, your scaling up your device, scaling up your resources in your existing device itself. Understood? Scale up.
Yes.
By scale out, let's say you have a building, the initial building with 2 stories, okay, 2 floors. By scale out, what you do is you build additional buildings here. Okay, instead of adding floors to the existing building, you build additional buildings here. Okay, again, as I told, it's not that vertical scaling is better or horizontal scaling is better, but logically, can you think of one limitation in vertical scaling?
Yes,
In
ma'am.
yeah,
Ma'am, we can't scale up every time. I think
yes,
it is a
yes,
limit.
correct. Very good, Sudhakar. There is a limit in scaling up vertically, whereas that is not the case with horizontal scaling. Take the example of the building itself. Can even if big towers and all that, they have a limit, right? You cannot simply keep on scaling up. You have certain limit of number of floors that you can build in your building based on your area, right? There are multiple, there are certain limitations to scale up, whereas that is not the case with horizontal scaling. And that is the reason, okay, your RDBMS supports vertical scaling in a much faster, supports vertical scaling, whereas your it doesn't support horizontal scaling. Understood? Okay, by vertical scaling, let's say you have a computer, you have a database. Okay, let's say initially that database have a limited storage and you keep on adding storage. After a particular point in time, you cannot keep on adding the storage to your computer. right? Your computer, a single thing cannot be, after a particular limit, you cannot still scale up. Okay, one advantage is that, okay, let's say this database goes down, some power issue or some internal issue with the hardware. Okay, when this goes down, your entire system will go down.
Yes.
Yes, ma'am.
Yes. Yeah, so there is a possibility of single point of failure. Okay, this is what we call it as single point of failure. If this particular DB goes down, my entire system will go down. Okay, horizontal scaling in RDBMS is kind of complex, and it is, implementation is going to be very costly. Okay, it doesn't support horizontal scaling naturally. Even if you try to implement it, it's going to be very costly when you are trying to implement it with RDBMS. And that's the reason most, if you are not, if you are not worried about the ACID properties, I told, right, RDBMS follows ACID properties. If you are not worried, if you are not considered, or if you are not worried if it follows ACID properties or not, many of the applications, it's not necessary. There is a workaround to achieve this. Okay, many applications other than banking or certain applications which require ACID go with NoSQL databases, because NoSQL databases supports horizontal scaling in a much efficient way. Do you want me to repeat?
No, ma'am. NoSQL database, accepting horizontal scaling, right?
Yes. Others, can I can keep on talking about the differences, the various criterias. I am just explaining the most important part, and the criterias you will have to consider when you are deciding which databases I need to consider, and what are the properties I need to consider. That is what we are discussing.
Ma'am, non-SQL database, what property has follow?
Yes, we didn't go up till that. No, we didn't. We are seeing the relational databases. Okay.
Yeah, yeah.
And I'm just saying, like I told, like vertical scaling is supported, right? So that's the reason I went to horizontal scaling, and then I just touched upon why NoSQL supports horizontal scaling. Yeah, I'll explain that later
Okay.
after this. Any other doubts so far with how your RDBMS is working? What I know, it follows ACID properties. Okay, we still have SQL databases. That time we will see more about it. Know how it supports vertical scaling and all. Okay, too much of theory, I believe. Okay, let's see about NoSQL databases, how it's just differing. Okay, how it's being stored and what are the advantages, and yeah, we will see about that. But is this clear? Any doubts so far? I'm just putting a pause here. If you have any doubts, let me know. Okay, can we have an MCQ now? Okay, yeah, let me create an MCQ and then we will start. If anyone of you want me to explain, we can straight away go to Mongo DB, but you need to understand how each of them work. Okay, if you want me to repeat, do let me know now itself. Just learning Mongo DB without knowing what is the use of it and why to use Mongo DB doesn't make any sense.
Explain it once time, but in simple way.
Okay, yeah. I'll do that. I'll just first, we'll finish up with NoSQL databases and then I'll repeat it again together.
Yes, ma'am, sure.
Yeah. I have added MCQ for data batch. Yeah, I have added for Baba batch as well. Yeah, how many of you are using Ubuntu system here? Can you just react with a thumbs up? Is anyone having Ubuntu system or Linux? Shubhankar is having, okay. Any other? Okay, you have Windows as well. Okay, Kanhu is having Ubuntu. Dheeraj, okay. So the points, no install. I was just asking for the installation process because if I try to implement in my system, okay, no Linux guys will be able to follow. It's most kind of similar, but I think most of you are having Windows, right? Yes. So can everyone raise your hand if you are having Windows or if anyone is having Mac? Just Windows alone, can you raise your hand? Like react in the thumbs up. Okay. What we can do is, I have already installed, yeah, I think like most of you are having Windows. I have already installed Mongo DB in my system. Even if I haven't installed and even if I show you the demonstration, it will not make sense because most of you are having Windows. So what we can do is, so anyone who have not installed Mongo DB can share your screen as in no, I'll give you few instructions you can follow so that others can also follow that. Okay. Yeah.
Ma'am, I'm not installing MongoDB.
You haven't installed, so can you share your screen? Not now, after the theory part.
Okay, ma'am.
Okay. Yeah. We'll see that. So now let's go to NoSQL. Okay. So NoSQL databases. Okay. As I told when we were discussing about the two different types of anything other than relational databases, okay, anything other than RDBMS, that's MySQL or SQL or Postgres, anything which doesn't maintain relationship between the tables will come under NoSQL databases. Okay, again, there are four categories in NoSQL itself. As I told, uh, okay, first one is there is no relationship. Okay, so again, the four different types is document based, document databases. Okay, there is key value database. key value DB. There is again wide column and all. Wide column DB and graph. Okay, so these are the 4 categories of NoSQL databases. It doesn't have any relationship, okay, between the data. Okay, so there are again for document databases, any example? Mongo is a document based DB. Okay, Mongo DB is a document database. Key value pairs, do anyone have any example for key value database?
Key value database and
It's Redis. Okay, Redis, Memcache and all are all key value. Wide column, any example? I don't know. Let me quickly check. Wide column. I think it's Cassandra. Yeah. Cassandra. Okay, and you have graph, you have Cassandra, and you have Bigtable, the Google's one. You have HBase, you have Cosmos. All these are wide columns. Okay. So in graph, even Dynamo is wide column, I believe. Yeah. Graph DB. I have no idea of the example. Let me check. Is Nebula. Okay. Examples are they are giving examples of the application which uses graph databases. But yeah, let's see.
Oracle.
Like there, what?
Oracle, no, ma'am. Oracle, no SQL database is also there. For
Oh,
graph
okay.
data.
Which is graph, is it?
Yeah.
Yeah, I have no idea on that. I haven't worked with that. Okay. So there are graph-based systems. So basically your data is stored, as nodes and you have relationships, okay, maintained in a graph structure. Okay. So these, anything, as I said, okay, it is not a you cannot say that it is relational or it is document. So anything other than relational are categorized into NoSQL databases. Is that clear? Okay, we are going to see about document databases, which is MongoDB. But there are certain properties which is in common with with all your NoSQL databases. We will discuss that first, and we will see how MongoDB works. Got it? Yeah. So as I said first, okay, there is no relationship, okay, in maintained. Okay, there is no relationship between the data. Let's say you have customers data, or you have another document. Let's say you have order data. Okay, each have their own entity. There's no relationship that is being maintained similar to how you have, right? So how NoSQL databases get stored is, let's say you have an order. Okay, you have order object and you have order ID, okay, which is some ID here, order price, okay, and then the products will be an array, okay, and each of the product will be an object. Understood? So how it's being made? So there is no necessity of relationship here, similar to how we discussed this part, right? The order, and you have a relationship with the product. Everything is stored as one single blob or one single entity here. So when I wanted to get the products of all the ID, I can simply go and get the order. I can simply get the ID and then get all the details of the products here itself. there is no need of maintaining a relationship and then querying it from an altogether a different table or a different file. Okay, entire thing whichever you need, okay, you are storing it as an entire object, so you can quickly query it, using, let's say I wanted to get all the products from order 1. I have the data here itself. If you see, if you observe closely, these are just similar to your JSON objects, key value pairs.
Yeah, ma'am.
Yes. So this is how your NoSQL databases are stored in very high level. Okay. Document based is similar to this, but graph is entirely different the way it's being stored. Again, byte column is different the way that byte column DB is being stored. So document based databases, this is Mongo DB, okay, generally stores the data in this format, which is a JSON kind of a format where you don't maintain any relationship. Is the first point clear? Everything is stored at one particular place. So when the user is trying to access, he or she do not need to relate to another document or another table to get the data. Okay, it is stored in one single blob, so you can quickly query all the data from there itself. Understood this? No relationship being maintained, each of them is unique, right? Like if you have a customer data, let's say you have customer data, customer document here, you will have ID, okay, you will have name, okay, and you let's say you have address, right? So address, again, it's a object itself. Address can have street, area, right, city, all these details in address, and this is how your customer will be stored. If you want to store the same data in RDBMS, what we will be ideally doing is, okay, create a customer table, okay, have ID as the first column, name, okay. This address has multiple data here, right? So we simply put address ID here, okay, and we maintain another table, address table, and have that ID here. So there is a relationship between these two columns. So when I wanted to get the address, this will have street, city, all those. Okay. So when let's say I'm getting Dheeraj's details. Okay. When I wanted to fetch Dheeraj's address, I will use the address. Let's say this address ID is 2000. So there will be an entry with 2000 with all the details of Dheeraj in a separate table. So a relationship is being maintained, two tables. You need to make a join and query. Okay, this is the relationship that we are talking about. Whereas when you come to document based databases, you need not do that because everything can be stored as a key value pairs, which is in similar to the format of JSON. Is that clear? No relationship being maintained. Can we go to the second point? Okay, yeah. Second point is it supports horizontal scaling. Okay, so instead of having the entire table and then increasing it vertically, which we were doing it in RDBMS, okay, instead of increasing the resources in the same instance or the same DB itself, in NoSQL databases are normally implemented as horizontal scaling, meaning, okay, there is, sorry for my poor drawing and handwriting. Okay, yeah. Okay, normally NoSQL databases, okay, are implemented, as partitions. You call each one of them as partitions or clusters, okay, or clusters. Let's say you need to store customers database, right? So you can have customers from from all over the world, right? So Mongo DB or Mongo or NoSQL databases, since it supports horizontal scaling, okay, you are not storing all the details of your customers in one single DB, rather splitting up into multiple instances of your DB and containing part of the data. Let's say you can have Indian customers in one instance, right? Indian customers, you can have US customers in another instance, another cluster, another partition. Okay. So let's say you have Malaysian customers in another. So or on a very high level, or Asia Pacific in one thing. Okay, in another region in one thing, another region in one thing. So you can basically split up, scale horizontally in a much efficient way in NoSQL databases. And understood what each one are called? They are called partitions or clusters in DB. But do you get a question now? So let's say let's say uh, I need a customer data. Okay, let's say I need a customer data of ID1. Okay, now since I have multiple instances of my DB, this will contain only a part of your entire data. Only Indian customers will be there in this instance. Okay, US customers will be there in this instance, right? So since your data is splitted across multiple clusters, multiple partitions, okay, there's one question that should arise. Let's say I wanted to get details of customer one from these four instances. How will I go and get the data from? Where will I go and get this data from? Will I go to first instance, or how will I know where should I get that data from? Any idea on that?
Ma'am, we have to know that where is like the customer is where, like
Where
query.
will you query? That data is also there in your database only, no?
Yeah.
But how will you query that? Don't think in terms of this example. Okay, this is just to demonstrate that your data is being partitioned across multiple instances, multiple clusters. Okay, for example, I have taken region as the partition. You can partition in any way. Let's say you wanted to partition based on customers of age 1 to 10 in one instances, customers of age 11 to 20. The way it is being partitioned can be anyhow based on your application. Okay, but after partitioning, since I have, if I let's say I'm partitioning based on country. Okay, if I go and ask for US customer data in this data DB, I will not get it, right? So how will I know where will I go and get? Okay, since it supports horizontal scaling, there is this problem of how will we know where to get our data from?
We can have a main server of having like country origin of that customer. Like from that we can get, okay, this customer is from this country, and so that we can like query
that is again a database.
Yes.
Yeah. So that's one way, yes, but again, that's again a database. You need to query it from any DB. Let's say that is also a NoSQL. If it's a SQL DB, yes, that will work. Okay, let's say that's also NoSQL, and you don't know where to get that from. So there are multiple ways to achieve it, Shubham. Like as you told, that's also one way. But generally, NoSQL follows. This concept is going to be a little deep. Okay, if you don't understand, let's leave it. Just know that point, that it supports horizontal scaling where your data is being splitted into multiple clusters. Okay, how to get, I will explain. If you don't get it, no problem, let's leave it and know later. Once you learn about MongoDB or any NoSQL databases further, I'll try to explain again. Okay, so there is this concept of hashing. Okay, there's this concept of hashing, and they have a range. Let's say you have only 1 DB first. Okay, let's say you have a range of 0 to 100. Okay, they hash a each customer will have a primary key, right? An ID or something. ID will be unique. Okay. Normally what happens is we will hash this ID, this unique primary ID, whatever we wanted. If it's a customer, if it's a primary ID, that unique ID, we will get it and we will hash it. Okay. Initially, let's say you have only one instance. Okay. When you are starting, when your company size is too small, okay, only one instance is enough. You don't need to scale it horizontally, right? So one instance is enough. So what you do is simply hash it. So this is the entire range. Let's say, for example, let's say you have 0 to 1 range. And if when you hash customer 1, let's say the value of the hash is 20. Hashing is just but using some formula, using some calculation internally to convert this 1 to 20. So same formula if we use, okay, second time if I try to hash 1, okay, second time also I'll get the same value as 20 only. So hashing is just a function where you have certain formulas or certain algorithms to convert this 1 to random value, and this should be the same every time I hash this value 1. Hashing, everyone clear, right? It can be
Yes.
any function, any operations you do. Okay, but that operation should be standard and it should result in the same hash value every time. If I hash 1 for the first time, it should give 20. Again, using the same algorithm and function, if I hash second time, again it should give 20. Okay, that's the concept of hashing. If you don't understand hashing, learn about it more. Okay, there are many default methods now to hash. Simply you don't need to define the algorithm, the function, you can simply give the value and it will hash it and give you. Okay, so let's say if your customer hashes 1, okay, it will get 20. So since you have only one instance, all will go in this instance. Okay, let's say after 100 100 or 1000 customers, your first instance is full. Okay, so now you will introduce a second instance. You are horizontally scaling it up. Okay, a second cluster, a second partition. Okay, now, okay, let's say you are hashing for customer 1, you get 20. Okay, now this range, right, 0 to 100 will be splitted up into 2, since because you have two instances. So if let's say you have hash of when I hash customer 3, my hash value is 70. If I hash customer 10, my hash value is somewhere around 65. Let's say I hash customer 15, my hash value is around 25. Okay, so what we do is, if the hash value is 20, okay, which is less than 50, I will go and store customer 1 here. Okay, if my hash value is greater than 50, I will go and store it in my second instance. Okay, this is for writing. Okay, let's say I have customer 10 and my hash value is 65. I will go and write customer 10 in my second instance. In the third instance, customer 15, again my hash value is 25. So my customer 15 will go here. So this is for adding. Let's say tomorrow, if I come and get, if I want the details of customer 10, okay, I simply hash this customer 10, I get 65. So now I know since it is 65, since it's greater than 50, I know I should go to the second instance and only there I get this data. Understood this concept? So this is how hashing and all works. How when you horizontally scale it like this, when your data is splitted up into multiple instances, again there are multiple ways. This is one of the common way which we use, right? So let's say tomorrow this also becomes full. Okay, tomorrow you add another instance, right? So this will be splitted up into 3. How do I split 33, 33, 30, 34, right? So 0 to 33 here and till 66 here and balance here. So this will not be there. So all hash values between 0 to 33 will go into first instance. All hash values between 33 to 66 will go to second instance, and all hash values between 66 and 100 will go into fourth instance. So tomorrow if I need, I can simply hash it, get the value, and based on the partition, I can redirect my request to read the data from. Is it confusing, or no? This is a very high level explanation of how you can query the data when your data is being partitioned horizontally. Any doubts on this?
No, ma'am, clear.
Clear? Others? horizontal scaling, how it's being supported.
Yeah, ma'am, clear.
Okay, how your data is being stored as one single blob, right? You no need to maintain any relationship. The third point is, yeah, if you don't understand this concept, no, please don't bother. It's kind of complex at this particular point in time. I do understand. Okay, just understand that it supports horizontal scaling in a much more efficient way rather than your relational databases. Third one is it is schemaless. Okay, let's say I have a product. Okay, product document, like I have a document which has details about product. Okay, so the first one will be ID. Okay, every object will have ID. Okay, every product will have name. Okay, okay, type also every product will have. Okay, let's take a mobile and let's take a dress. Okay, mobile will have something called screen size, right? Screen size will have a property called screen size. If it's 6 inch or 5 inch, every mobiles will have. But since I'm going to store all the product in one single document, I cannot expect, let's say ID 1, name, sorry, ID 2, let's say I'm storing dress here. Let's say this is Samsung mobile. Okay, this is some clothing category. Okay, it will have type. Okay, here I don't have property of screen size, right? Do we have screen size property in clothing?
No, ma'am.
No, right? But we have size, but that's a different property, and screen size is a different property. Again, let's take another example. Let's take washing machine or that and all. Okay, you will have details of what's the power and all, right? That and all will not come into clothing. So each product have their own properties, right? Different properties. Let's say you have decided, okay, you have decided to store this in a relational database. Okay, what you will end up doing is, okay, let's say you have a product database. Okay, let's say ID, okay, name, type, okay, screen size. Okay, I also need power details for all the electric devices. Okay, I also need to add additional no, assume this is to be a no, I can have colors for my clothing, right? Size for clothing, or wood type if it's a furniture, right? So let's say I'm storing all the product in this big table itself. Okay, let's say my product one is a mobile. Okay, I say Samsung, no, it's a mobile. Okay, screen size 6 inch, but all these details, okay, yeah, color you still have in the mobile. Okay, but wood type and all is empty, right? Empty. Color can be something, it's still applicable to mobile, but these and all will be empty, right? Let's say tomorrow I store details of a furniture, a chair or something. Okay, let's say it's a chair, type is furniture. It doesn't have screen size, it don't have power. Color, yes, applicable. But size also, yes, size also might be applicable in for certain furnitures, but this is you will have some data here, right? So if you can see here, okay, different products have different properties. If you end up storing it in a relational database, you need to add all the different properties as a column, even though it is not valid, it doesn't make sense, right? Here all these doesn't make sense, right? You will end up wasting few spaces here and there, okay, just because that property doesn't make sense here. Okay, as I told, you will have to have a schema before entering entries into the table. Okay, this is the schema. You have to define all these columns first, right? All the columns first in order to add data. You will end up having irrelevant columns as well. When you take NoSQL databases, since it is schema-less, You need not define this schema like this. You need not tell your system that I'm going to have ID, I'm going to have name, I'm going to have screen size. You need not define this schema. Okay, you can add whatever you want. Let's say you are clothing. Okay, screen size is not applicable to clothing, right? Size is applicable. Let's say it's 45 or 50 something size. Okay, but I can entirely leave that screen size. I need not mention and then reserve a space for it. Let's say tomorrow I'm storing furniture. What are the properties applicable? Name, let's say it's a chair. Okay, uh, type is again furniture. Okay, here color, wood type will be applicable, right? I need not mention size, I need not mention screen size. Okay, because it is schema less, I can define whatever field I wanted to, whatever properties I wanted to. Okay, I am not I need not save an empty space or waste a space or create unnecessary unrelated properties. Okay, when it is not applicable. Since it is schema less, I can go with whatever is applicable and save only that information. If it is not valid, if screen size is not valid for furniture, I can simply ignore. Understood what's the difference between schema and schema less?
No, ma'am.
No? Any doubts, Swapnil? What doubt you have?
I didn't get the difference.
Okay, you didn't get the difference. So by schema, first you will have to understand what schema is. Okay, whenever you wanted to define a table in a RDBMS, you need to define what are the column, okay, in my table. What are the different columns I'm going to have in my table? What are the different types that my columns are, no, type of the data of each column. My name is going to be string, my ID is going to be number, my type is string, screen size again it's going to be double, right? You need to define all these, okay, before entering any data into the table. You need to define all the property, all the column names and the column type as well. Okay, that is what we name as schema. Understood the schema part?
Yes, ma'am.
Okay, so now when I say product table, okay, certain properties, for example, okay, size and certain properties like screen size is applicable only to mobiles or TVs, or only for certain products screen size is applicable. For furniture, the screen size is not applicable, right? So what you will, since you have to define the schema before itself, you will end up creating a column for screen size, but in the furniture row, in this particular row, you will leave this empty. So what we are ideally doing is, empty space is created and you don't store any data for furniture. Okay, because screen size is not applicable to furnitures, right?
Right.
Similarly, you have different properties which are applicable only to certain products. Since RDBMS is schema based, okay, you will be in a situation to define all the properties, okay, even if it is not applicable, okay, and because you will end up having unrelated data, right? Do you have screen size for furniture? No, this is completely irrelevant, right? Even just because you need to have a schema for RDBMS, you end up having this column. Okay, but that is not the case. Is that part clear? What's the
Yes, ma'am.
problem with this? Okay, that is not the case with NoSQL databases. NoSQL databases are basically schema-less. By schema-less, what do I mean is, you do not need to mention what are the keys I'm going to store. Okay, you need not define the schema beforehand. Okay, as and when you get the data, you can simply add it in your document. You need not define that I'm going to define ID, I'm going to have name, I'm going to have type, I'm going to have screen size. You need not define that schema beforehand. Okay, simply as and when you get a product, you can simply add. So since it is schema less, okay, when I am trying to add clothing, okay, screen size is completely irrelevant to clothing, right? I need not add screen size. Okay, I need not add something screen size and leave it empty here, because adding screen size is not mandatory since it is not schema list. You can have whatever properties you want and simply add it. You need not define that all the properties, right? Similar to how you defined all the properties here, you need not do that for NoSQL databases. So when I'm trying to add furniture, I can, since it is a JSON kind of data, I can simply add whatever is applicable to furniture. I need not include screen size here. Okay, screen size is not applicable, so I can simply ignore the key and the value here. Okay, since this is possible just because it is schema-less. Understood, Swapnil?
Yes, ma'am.
Okay, so I am adding only the details whatever is valid. Let's say you are signing up. Let's take another example. You are signing up. Okay, for certain exam, for whenever a user is signing up, all informations might not be given in one go. Okay, some user might not give their phone numbers when registering, but some users might give, right? So if the user is not giving phone number, I can just store the name and the ID. If let's say customer 1 is not giving the phone number, I can just store the name and the ID here. Okay. When the customer 2 is storing, adding data, if he or she gives the number, I can add phone data here. Okay, I can add and delete whatever data I want as an as and when I wanted it. Like whenever the user gives some data, I add it, else I don't add it. Understood? Because this is schema list. You don't need to mention these are the properties I'm going to add, or if there is any additional properties also, you need not need to mention that because it is schema list. Understood that point? Any doubts on this schema list?
No, ma'am, here.
No? Okay. One other thing. Let us say tomorrow another property comes up. Okay. Another property comes up for product. What are the other properties you can take as an example for products in general? Probably if you are storing laptops, RAM size will be there, right? Let's say laptop category comes in tomorrow. Okay, I'm going to sell laptops as well. So adding an additional, okay, editing the schema, right? Editing the schema or updating the schema is not straightforward in RDBMS. You cannot simply go and add additional column, no, as in it's costlier. Yes, you can add additional column, but no, you will end up with, you will have to put a log for all these, okay, so that nobody modifies when you are trying to edit it. And then on a very high level, it's kind of complex process, okay, to do it in real time. If your data, if this table is already in live, simply adding an additional column is not that easier. Okay, you will have to put a lock on all the existing rows, have a little downtime. By downtime I mean your customers will not be able to access any data from product. Okay, and then add an additional column and then add computer related data as here. Okay, but these are all will be empty. Understood? Like basically editing the schema in RDBMS is costly process. Okay, whereas that is not the problem here. I can simply go and add, let's say name, ID, phone. If tomorrow, if I wanted to add RAM, sorry, this is customer document, right? So let's say you are adding here. Okay, I can add ID, name, type. I can simply add that as a RAM, as a new property, since it is schema-less, right? I can simply add that new field here and then add it in my document. Okay, this is much like very easier because no schema. I can add whenever, I can add whatever property I want. Okay, so this is much easier editing the schema, or there is no, since it's schema less, basically there's no problem in editing new or adding new properties. Like when it is RDBMS, adding a new schema or editing the existing schema is not straightforward. It is very costly. It's a very expensive process. Understood? So when you have an application which involves, frequent editing of the schema, always go with schema less, that is NoSQL databases. Okay, but in banking applications and all, mostly on a very high level, transaction details are not going to, you are not going to add additional column or additional property in transactions, right? It's not going to be that frequent, right? In banking transactions and all, do you think as and when new properties will get added? It's going to be the same sender
No,
ID,
ma'am.
time, detail, amount. That's going to be constant, right? The schema is not going to change. Okay, so banking applications and all, they have no problem with editing the schema and all. They don't face it generally. So they are fine with having relational databases because it supports ACID properties. Okay, that is important. Okay, because yeah, I'll speak about ACID properties and all later. But yeah, let's finish it up with so much now. Like this is enough for today. Let's too much of theory, I do know that, because if I don't explain all these, right, and go straight away with the Mongo installation, right, later you will feel difficult or not understand when you interview it's a general question, right? Whenever you develop an application, whenever you choose a database, you should be in a situation to tell why you chose a particular database. Even in NoSQL, Cassandra and MongoDB are entirely different. Each have their own advantages and disadvantages. You should be able to differentiate, and you should be able to give explanation of why you chose a particular DB. Okay. Let me quickly repeat what we have seen so far and see the installation process. Okay, just the installation and setting up. We have 15 minutes left. I'll just repeat. Okay, so databases are generally classified into relational databases and NoSQL. Okay, anything other than relational databases are grouped under NoSQL databases. Okay, certain examples are SQL, MySQL, Postgres. Okay, here we have MongoDB, Dynamo, Couch, and all those. Okay, so in relational databases, normally your data is stored in the form of tables. Okay, each table have rows and columns. Your column have the properties, that is whatever data you wanted to store in that table. If it's a customer table, your properties are going to be ID, name, and all details with respect to the customer. Okay, so each row is each entry, right? Each row is each customer details, and columns are the a particular detail of a particular customer. Okay, name, address, the database, and region. Okay, so this is how data is being stored in relational databases. Okay, uh, we'll just come to the word called relation. Okay, let's say take an example of customers who make orders, multiple orders, and each order can have multiple products. So if you want to design that in an order in the relational databases, you end up having a different table for order, which will have all related details about the order and also the customer ID who made the order. Okay, else you will not be able to find out the orders made by customer one. You will not be able to find out if you don't have a mapping for the order ID and the customer ID. You need to have that. Only then you will be able to find out what are the orders placed by customer one or customer two. For that, you will end up having a separate column here. Okay, a separate column here, and that is basically a relationship with the customer table. Okay, every ID in order table will be present in my customer table, and there is a relationship between these two tables. Got it? So this is what we call it as a relational databases. Normally a relationship is being maintained between different tables. Similarly, each order can have multiple products. If you have a mapping with no order ID, only then you will be able to get all the products of order ID 1. Okay, else it will be difficult to map like what are the products ordered for order 1 that you will not be able to get if you don't have the mapping for order ID. Okay, so you need to maintain few relationships here and there in order to get few informations in relational databases. Okay, coming to that, it's a relationship. Again, you have to define schema. It's relational first point, second is schema. Okay, by schema I mean whenever you wanted to add few data in the table, okay, you need to define first what are the columns in my table, what are the types of each of the column, the data type of each of the column. All these you will have to define it first. If you don't have a schema, you cannot add entries into your table. Okay, next thing, important thing is RDBMS follows ACID properties, which stands for atomicity, consistency, isolation, and durability. We can explain, have few examples with this at later point when we see SQL databases. But your NoSQL databases do not follow this ACID property. Okay, and that is the reason all banking applications, all financial related applications do not go with NoSQL databases because ACID properties are not followed in NoSQL databases. Okay, there are few workaround in Mongo and all to follow, but it's not in a full percentage and all. Okay, next thing is your relational databases supports vertical scaling only. Okay, so horizontal scaling, achieving horizontal scaling in RDBMS is a tedious process, and it is not that of efficient to achieve in a large scale. Okay, what is horizontal scaling and vertical scaling? I gave you an example of a building. Adding floors, okay, to an existing building is called vertical scaling, which is otherwise called as scale up. Okay, if I have a computer with 16 GB of memory, if I need to expand it, I have two ways. Either change the 16 GB to 32 GB, else, okay, buy another computer with 16 GB. Okay, there are two ways. Okay, adding another computer itself is scaling out. Okay, that is horizontal scaling. Changing my existing 16 GB and adding resources on top of my existing computer itself will come under vertical scaling. Understood the difference between Shazia? You were the one who asked me to explain. Any doubts with that? What's vertical scaling and horizontal scaling? Any doubts so far? Since it supports vertical scaling, if my database is down, your entire application will be down. So this is what we call it as a single point of failure. Whereas when you go for horizontal scaling, you don't have a single point of failure. Okay, even in horizontal scaling, what happens internally is each of the cluster, right, each of the instance which we were talking about will have multiple copies. Okay, copy 1, copy 2. If this copy goes down, this will still be alive. Okay, so there's no single point of failure in NoSQL. Let's come to that later. But vertical scaling is clear. Any doubts so far with how RDBMS is working? Yes, no, I know it's too much of a theory today, but yeah, no, for the first class alone, it will be like that. Okay, so second one is NoSQL databases. Again, it has no relationship. Each one of them have its own data, whatever is required. You don't need to maintain another relationship and query the data from there. Okay, there's no relationship being maintained in NoSQL databases. Broadly classified into 4 types: document, key value, wide column, and graph DB. Okay, each one's implementation is different. We are going to see about document databases only, which is nothing but key value pairs, right? So you will have it as a single blob of data which you can query. You don't have any relationship. Again, this is a schema-less, right? Sorry. Okay. So this NoSQL supports horizontal scaling, meaning you can partition your data based on any criteria. For example, I have partitioned based on the region. Okay, you can partition the data into different clusters. Each one of them is a different cluster, and each of them have a part of a data of your entire application. Right, this instance contains users of India, right, users of US, users of Malaysia, right. This is horizontal scaling. Okay, so this part was, I was trying to explain how will I know where should I get the data from. Okay, let's leave this part. Okay, but this horizontal scaling is supported very efficiently in NoSQL database. Third point is schema list. You need not define the schema. You need not define all the properties before entering the data into your document. Okay, that's not necessary. As and when you get data from the user, whatever you need to store, you can add it and as and when you get. You need not mention what are the field I'm going to have, what are the value types, that and all is not necessary because it is schemaless. Okay, I gave you an example of products and all. Similarly, editing or modifying the schema is a tedious and process in RDBMS, whereas it's of no point in mentioning that because it's schemaless. You can simply add and remove whatever properties you want as and when you have the data. Okay, so this is the high level explanation of how no RDBMS and NoSQL works. Any doubts on this? Class is too silent. 29
No,
of
ma'am.
you are here.
No, no.
No?
No, ma'am.
Okay. Can any one of you quickly share the screen? We'll go with the installation of MongoDB.
Shall I?
Yeah, sure. Okay, let me stop sharing. Yeah. Go ahead, Swapnil. Go to your browser, type in Mongo Compass. Okay, so this MongoDB supports two versions, the community and the enterprise. Okay, enterprise is basically the paid version with additional features and all. Okay, we do not need that. Okay, we can install the community edition itself. Okay, that's free with limited features, but that's enough for development purpose. Okay, and these are the two versions. Okay, and we are going to install community edition, and this MongoDB Compass is GUI. Okay, generally if without this also you can work on. Okay, without MongoDB or MongoDB Compass also you can just simply install MongoDB and then work. Okay, but this MongoDB if you don't install MongoDB Compass, okay, you will have to work with command lines, right? That also you can do, but this Compass is much more efficient. Just go inside the second link, not the Atlas one. Okay, yeah, MongoDB Compass, yes. Yeah, can you just go down, scroll, download? Yes.
This one, ma'am?
Yes, download. Okay, can you just scroll down? Yeah, Windows, yeah. Can you just click download button here? Based on your system bits, you can just configure that download. Yes. That's all will be automatic. It will be correct. Yeah.
Oh, time लगेगा, ma'am. It will take too much time. I think 112 MB.
Okay. Do anyone of you have Wi-Fi? Are you using it Wi-Fi?
No, ma'am, on mobile.
Yeah.
Okay.
Can I stop sharing my screen?
Yeah, but do anyone of you have?
Yeah, ma'am, I have.
Yes. Can you share screen, Adil? Because I can know I have already installed. I cannot demonstrate in Windows machine. So that's the reason. Yeah, Adil is doing it. Okay. So this is the Compass one, right?
Yeah,
Can you
ma'am.
just unzip it and then install it? Yeah. You have unzipped. Okay, just double click it. Open.
Yeah.
Extract to a separate folder.
Which folder, ma'am?
Yeah, extract to.
Extract
Click
to, yes.
extract to. Yeah.
Yeah.
Create a new folder here, and then yeah, downloads. That will do. Just give OK.
Here, okay.
Yeah. Yeah, you will find a folder inside downloads.
Yeah.
Yeah, that one. How do you install? Yes, that one application. Can you run that? Next, yeah. Yeah, just give all next.
Get
Started. Yes. Give start using complex. Yeah, can you just click on connect? Okay, if you can see here, your Mongo is getting started in the port 27017. Okay, when you try to install Compass, by default your Compass will install Mongo as well. If you don't want Compass and you just wanted to install Mongo only and you can work with terminal, you can go and install Mongo 5.0
Ma'am, Compass
community.
is this graphics user
Yes,
interface.
yes. Similar to how you have Workbench, right? You have this connection refused. What happened? Okay, can you go to your command line?
Git bash.
Sorry. Yeah. Your env. No, in Windows you will have the command prompt, right?
Yeah, ma'am.
That
So I
one.
have git bash also.
Okay. Any command prompt will work. Can you just type in Mongo? Okay, it's not recognized. What you need to do is you need to configure environment variables. Okay, can you go to installation part where you had that folder?
On the download.
Yes, install. Yeah, inside. Mm, there should be something called. Can you go into resources?
Type Mongo DB.
Yeah. Resources. No, not this one. Back. You will have a bin folder. I'm just trying. No, not here. Can you just go to Windows, local disk C, CC?
See.
Yeah. Program files. You don't have MongoDB here.
Yeah, ma'am.
Go
Yeah,
to the
the
desktop
program
and
files
select the
x86.
program file and go to
You
the
should
details.
see a folder called MongoDB here. Yeah, go to downloads.
Yeah, ma'am.
Go to downloads.
Downloads. Okay.
Yeah, that folder.
That MongoDB
Yeah.
folder.
Yeah.
Okay, ma'am.
This is the application itself, right? So any of your Windows users have already installed Mongo?
Yes,
I
ma'am.
have.
You have. So what is the process you followed?
File location. You open the file location. ma'am.
We have to need set environment variable
Go back
for
and
Yeah,
MongoDB.
you need to set environment variable, and also we need to find where did you find the bin folder from?
Inside the C.
you have to
Inside C.
set up MongoDB and type the right key and you have in the file location.
Sorry, can you just come again?
And go to the installation exe file of the MongoDB and right click and here the some option of the go to the file location.
Okay,
Make
the
the file
installation is at the downloads itself, you're saying?
No,
Go
installing,
into the program files.
Okay,
yeah.
program files. Okay.
Inside program.
Back.
We don't have
Scroll.
MongoDB here, right?
Yes.
Yes, it's actually not installed.
Yeah.
Just the compass is being installed. Just try connecting it again.
Ma'am, but
Ah.
without username or password, how to
Yeah, that is what I'm also wondering. Like, yes, Prague, that is the location, MongoDB server 5.1 bin, but he doesn't have that MongoDB folder itself in the program files.
Or ma'am, should we installed incorrectly? I think.
Okay, can you go to the site? Which one did you download?
Same site.
MongoDB Compass.
Yeah, ma'am.
This is Atlas.
From here.
Okay, Compass,
This.
you download. Okay, so from here, do you have any other different package here instead of zip? No, not that one. The package one.
No, ma'am. Only zip is here.
Zip is here.
Should I download once again?
No, that's not necessary. Just go to the downloads again and then try to double click. If you, I'm just wondering where that installation process folder itself has not come. Right, just click on.
Hello Mohammed, मैम मैं बताऊं? Hello.
Yeah, बोलना भाई.
मोहम्मद जो फाइल तुमने रन कर रखा है ना,
हाँ.
ओपन करो, इसे क्लोज कर दो फाइल को.
ये फाइल?
हाँ, ये पूरा क्लोज कर दो. जो ये फाइल ओपन है इसे भी क्लोज कर दो. इसे क्लोज कर दो. जो फाइल ओपन है ना, ये फाइल.
ये डाउनलोड वाला फाइल भी?
हाँ, ये फाइल, हाँ बता दो.
ठीक है.
अब सर्च करो
यहाँ पे MongoDB.
हाँ. अब इस पर राइट क्लिक करो, फाइल लोकेशन.
या ब्रो, ये खुल रहा है डाउनलोड में, देखो यहाँ नीचे आ रहा है.
That's in downloads. Yeah.
Yeah. और okay.
Can you just click in update? The update one before license. Yeah.
Yeah. Not opening it.
It's not opening. Okay. The application is installed, but the Mongo is not being available in program files. But that's not the problem with Ubuntu, right? If anyone have installed, I just got that installation page in the first go itself. That is not available here. Yeah, those of you who have already installed Mongo in Windows can help, else I'll check how to install in Windows and then get back tomorrow. Okay, that should be a pretty straightforward one. I'm not sure like why that installation. Do anyone of you get any other page when you are trying to install, when you're trying to download and install? Subhash, Prague, who have already installed?
No, ma'am, it's same.
Same process. You just run the application itself after downloading the file.
Yes, ma'am. Like for us, like the file was there in program file. Maybe the installation process is not like properly done, and CLI has not been installed. Maybe.
Do any one of you who are installing it, but now were you able to do it? Okay, no problem. It's already time up. Okay, we will have the MCQ and we will end up today's class. We will see the installation. Probably there's something to do with the Windows. I know that we will have to configure env, but in the first place, I don't even have the folder in the program files, right? That's the problem. Yeah, reinstall. Adil, what you can do is try deleting all your files which you have extracted. Okay, try to reinstall. That will also work. Rajnish
Yeah,
has,
ma'am. I'm uninstalling the MongoDB actually now.
yeah, just uninstall and do. But I can just share my screen and then let you know. Give me a minute. So this is, can you see my screen now?
Yes, ma'am.
Yeah. So once you have installed Compass, okay, the Compass is just a GUI, okay? It's not the Mongo is being installed, okay? When you try to install Compass, by default, Mongo also will be installed. So when you try to connect locally, it will connect to your local databases. Okay, the database is residing in your system only, it's local. Okay, these are default collections, okay, sorry, default databases created by Mongo itself. Do not edit anything here. If you see, I'll say what are collections and all tomorrow. We will see the terminologies tomorrow. Okay, but these are default databases created in local. Okay, so there is also one other thing called MongoDB Atlas. Okay, Atlas is just, now we are having all the databases in local, right? Okay, so MongoDB Atlas is just a database as a service. Okay, it is in cloud, it is a cloud based model. So instead of having all the data in local, you can deploy the database in AWS or any cloud, and you can get that as a service. Okay, MongoDB Atlas is just the cloud version of your MongoDB, and all your data will be in the cloud, in your cloud MongoDB Atlas application, instead of having it in local. Once we are done with this installation, okay, we will be working with MongoDB Atlas only going forward, because no, it's easy comparatively, and you also have the data in the cloud, as and when you want, you can access instead of having it in local. Okay, once we are done with this local, I'll show you how to do it, MongoDB Atlas one. That's the since it's a cloud version, there's need not to do any configurations and all. It's pretty straightforward one that I can show tomorrow. Yeah. Okay. Prague, Adil, Prague has sent some link. Okay. For others also, whoever is trying it now, trying to install. Okay. Try to install and let me know. Install Mongo Compass alone. Okay. You should be able to, your by default, it will run in localhost 27017. Okay, and you should be able to connect. You can simply click the connect button and it will show all these default databases created by Mongo. Okay, so let me add the MCQ. Only 2 is done, is it? Okay. I'm adding the third MCQ. Give me a minute. Adil, if nothing works, okay, you have installed Compass. Only thing is the MongoDB is not being installed. What you can do is you can just install the MongoDB 5.5 alone separately and then try to connect it. I think that should work without any problem.
Okay, ma'am.
Okay, I'll share the link in the chat in a minute. I've added the MCQ
Actually,
for Baba batch. I have added the MCQ for Tata as well. Yes. Whoever.
ma'am, actually, I just checked my downloads and I found that I
Mhm.
didn't download it the zip one. I downloaded the MSI one. So maybe that's
MSI
why
one.
it's wrong. Yeah,
Okay.
the exe file only.
Did you try that, Adil? Yeah, try that.
Yeah, ma'am. Okay.
What I was suggesting is, okay, even I did it in this way only. I first installed Mongo DB. Okay, just the Mongo. If you can go here, Mongo DB on, Windows. Okay, this is just the shell part, just the Mongo DB server. Only that is not working for you, right? The compass part is done. So just follow this instructions to install your MongoDB server, and then you should be able to do it. Okay, don't do the do the community edition only, not the enterprise one. Download the installer, probably, yeah, this should work, I believe. The MSI one, what Prague is telling about. This is Mac, right? Windows, yeah. Download the, instead of zip, download the MSI package and then try it. Okay. So let us create another MCQ. The last one. The recent MCQ which I added also is kind of tricky. Okay, know how destructuring works. Only then you will be able to answer. Sorry, I have taken your 15 minutes of time. Yeah, I'll wind up in a minute. Yes, added the last MCQ for Baba. Yeah, added it for Tata as well. Created attendance. Tomorrow we will see how to create, how to edit, delete, update, and all. No more theories. Okay. I know today's class was too much of theory. Yeah, only theory I can say. Okay, but that is important. Okay, without knowing why we are choosing certain databases, what are the properties, what are the features. Okay, it's not like one over the other, but based on the use cases, what DB you choose is important. So you need to know all of these. Okay, and that's the reason I took an entire class to explain the scaling part and all. Right. So yeah, tomorrow we will see how to create, update, delete, and all the operations with MongoDB. Okay. No, tomorrow I'll try to, any one of you can still share the screen and, start the installation process. Okay. If time permits, like if you can also do it by your own, do install Mongo DB Compass in your system. Okay. At least tomorrow we will install it. Okay. Yeah. Okay, guys. Good night. Any more clarifications? Any doubts? No, yes. Any doubts with whatever we have seen so far? Hmm. Pragyanshu, were you part of any other batch earlier?
Yes, ma'am.
Okay, okay, got it. Okay, any doubts? Others? Dheeraj, Jibrar,
No,
Swapnil?
ma'am.
Yes, Dheeraj. No? Okay. Rajnesh, Ibrar, Sapna, Shazia, any doubts? Shubham?
No, ma'am. Thank you.
No. Yeah, thank you, Sapna. Good night, Ibraria. Good night. Others, any doubts? Shiva, Shubham. 8 of you are here. Good night, Pragya.
No, ma'am.
Yeah, good night. Shiva.
Where is the bin folder
ma'am.
inside?
Okay, bin folder is inside program files, MongoDB /5.0/bin, I believe. Yeah.
Slash 5.0.
Are you getting the MongoDB folder in the program files?
See. No, ma'am.
In the program files, there should be a folder called MongoDB. Did you install MSI through MSI?
Yeah, ma'am. I installed the Compass through MSI. Now I'm
Okay.
installing the MongoDB.
Okay, you're doing it by no separately. Okay.
Yeah, ma'am.
Even then you didn't get it. Yeah. Can you share the screen now?
Yeah, ma'am.
Yeah, sure. We'll just figure out because even I don't have Windows system. I'll not be able to figure out tomorrow as well. Oh, let me stop sharing. Yeah, you can share now, Adil. Okay, this is the page which I was looking for, right? That one that is completed. You should see in local program files. Yeah, yeah, MongoDB, right? Let it complete. So this is through the MSI, right?
Yeah, through the which you gave me.
Okay, okay. Probably then that's the issue. Not issue, even with tar we should be able to do it, but there is some other different process that should be followed. Okay.
It will take lots of time.
Okay, what you can do is go to MongoDB inside server 5.0 bin. Yeah, copy that path in your top, right? Like the location. This
Okay,
piece,
yeah.
yeah. Just copy that path.
Yeah, ma'am.
Go to environment variables. Just in your Windows, type in env. Okay. Yeah, edit. Yes, that one. No, not this one. System environment variables. Yes. So go to path. Can you see path here in the first box? Yeah, third one.
Third one, yeah, ma'am.
Yes. Edit. Yeah, just add new. Yeah, paste that path. Okay.
That's it, ma'am.
Yes. Okay. And then
Slash.
save. Yeah. Save and then okay. Got it. Now close your CMD and then open it again. Your Git bash or your CMD will be the right one, I believe. Yeah. You can just type in Mongo here. Okay, got it. Yeah, this is now you should be able to connect. But even now, if you see here, couldn't connect to server caused by no connection because target readily.
Because of installing.
Okay, yeah. That itself is not completed, but your Mongo command is configured. Okay, your shell is installed with version 5.0. Finish.
Connected.
Okay, connected. Yeah. Done. Okay. Okay, Adil. Yeah, thank you so much.
Yeah,
Probably like that MSI is a problem. If everyone try to install that one, there should be no problem with
the
local installation. Yeah.
This one, ma'am. This one is
This one is the default database is created by your Mongo. You can also create your own databases on top green button, right? Create database. This is the GUI. Okay, you still have queries and all, which you can do it in the command line itself. Okay, let's stick with Compass, and mostly you will be working with Atlas on the cloud version, Atlas. So this is just to show you there are, in local also you can do it. Yeah.
So we have to download the Atlas version also.
No, not Atlas is the cloud version of your database. Okay. Everything is there in the internet. You need to log in with using your email ID and then set up. You are done with it. You don't need to do any
Download
installation.
any. Okay,
Yeah.
ma'am. It was
Because
on
it's
the
not
browser.
local. Yes, it's in the browser itself, and databases are in, you basically, it is a database as a service. You get the database and then deploy it in any of the cloud. Okay, tomorrow I'll show you the installation of, how Atlas works. You just deploy that particular cluster in the cloud, and you will be able to access that.
So, ma'am, it was the query part of MongoDB is similar to the RDBMS relative database.
Not exactly. Okay. In RDBMS, you'll have to mention the column name. You'll have to make
Yeah, ma'am.
joins. Yeah, not.
Actually, we learned MySQL in college, so I think
Yeah,
it's similar or not. I was asking that.
not similar. Kind of different. We'll see tomorrow. We'll see the installation of Atlas, and then we will see the common operations, and then we'll see tomorrow. Okay.
Okay, ma'am. Thank you, ma'am. Bye.
Okay. Bye. Rajneesh, any doubts? Dheeraj?
No, ma'am.
Okay. Cool. Good night, guys. Bye.